I am Prajwal and today we are going to discuss this problem IPC Trainers. This problem is rated as easy on CodeChef and you might require some basics of greedy algorithm and use of set in your favorite programming language to solve this. So guys, if you haven't read the problem yet, go back and read it and then come back and watch the solution. With this, let's begin. In this problem, there is a programming camp happening and this programming camp is happening for D days. Now we are given that there are n trainers and each trainer will arrive on some day during these days to teach in the programming camp. So for each trainer we are given a value d of I, that is the arrival day of the ith trainer. So let's say that some trainer arrive at this day, then other will arrive at some other day, and they will stay from their arrival day till the end of this programming camp. Now it is given that each trainer wants to teach T of I lectures, T of I number of lectures. They can teach this lecture from the arrival day to any day till the end of this camp. Now we are given that we are only allowed to take at most one lecture in this programming camp per day. So there might be the case that all these n trainers might not be able to take all the lectures. Hence, for each lecture that the ith trainer is not able to take, his sadness increases by s of I. So in the program, we are asked to find the minimum total sadness of all the trainers at the end of this camp. The constraints given to us are, we are given test cases from 1 to 10, the number of days for which this camp happens and the number of trainers can range from 1 to 10 to the power 5. The arrival day and the number of lectures will range from 1 to d, and the sadness level can be anywhere from 1 to 10 to the power 5. Let us look at some test cases to understand the problem. In the first test case, the programming camp is going to happen for 3 days, 1, 2 and 3. The trainer 1 will arrive on day 1 and trainer 2 will arrive on day 2. So let us say on day 1 we have only one trainer, so trainer 1 will take the lecture. On day 2 we have trainer 1 and 2 both, let us have trainer 1 take the lecture. On day 3 we do not have any new trainer, we have only the second trainer whose lectures are left, so trainer 2 will take the lecture. Overall, trainer 1 took 2 lectures and trainer 2 took only 1 lecture. The final sadness of 1 is 0, while the final sadness of 2 is 100. The total is the sum of the two sadnesses, hence answer is 100. In the second test case, the training camp is going to again happen for 3 days, 1, 2 and 3. Trainer 1 will arrive on day 1, trainer 2 will arrive on day 2. We will have trainer 1 take the lecture on day 1, trainer 2 will take the lecture on 2 and 3. So in overall, 1 took 1 lectures and the trainer 2 took 2 lectures. The final sadness of both the trainers in this case is 0 because they took the corresponding lectures given in the question. The answer is also the sum, which is 0. So guys, try to do the same thing for the third test case yourself. Moving on to the solution. In this problem, we are given n trainers characterized by their arrival day di, the number of lectures that they want to take t of I, and their sadness value s of I. So now let us consider some day d belonging to 1 to d. And now on this dth day, let's say we have some trainers A1, A2 till AK that can take the lectures. Basically on this dth day, all these trainers from A1 to AK have some Ti greater than 0. Now our goal is to minimize total sadness. The keyword total is important here. So for this, we have to choose some trainer optimally such that we minimize the total of all the sadness. To do this, let us first sort all the trainers by their sadness value. So let us say we get a sequence B1, B2 till B of K. In this sequence, S of B of I is less than equal to S of P of J for all I less than J, which means that these sequence is sorted by the sadness value. Now it is pretty much obvious that we will always take the trainer that has the maximum sadness value. Hence, we will always take BK. Now let us look at why is this true. So let us say on the dth day, f of BK is the final sadness that we get when we choose B of K. That is, when we choose the trainer with the maximum sadness. So this can be written as T of B of 1 star S of B of 1, the sadness of the first trainer. And then we can write at the end as T of B of K, and we will subtract 1 from this because we are taking B of K on the last day, on the dth day, and we star it with S of B of K. Now let us say we take any other trainer that is not B of K, which means we take any other trainer that has sadness value less than the sadness value than this, less than or equal to the sadness value of the last trainer. So for simplicity, let us take an example. Let us say that we take the first trainer. So in this case, we take B of 1. The sadness value can be written as T of B of 1 minus 1 star with S of B1, and we will continue this process up till T of B of K star with S of B of K. Now to compare these equations, let us subtract 2 from 1. So we calculate f of bk minus f of b of 1. So for all the elements that are present in between from 2 to k minus 1, they are exactly the same in both the equations, hence they will get cancelled. Now we will get T of B of 1 S of B of 1 plus T of B of K S of B of K minus S of B of K, and from the second equation we will get T of B of 1 S of B of 1 minus S of B of 1 plus T of B of K S of B of K. So now as you can see that these terms are exactly the same, hence they will get cancelled. So finally we are left with minus S of B of K plus S of B of 1, and as we know that S of B of 1 is less than or equal to S of B of K, so this is negative. Now let us calculate f of B of K minus f of B of 2. So from above we can say that this is equal to minus S of B of K plus S of B of 2. So this is also less than or equal to 0. Now by induction we can say that f of B of K minus f of B of I, where I is less than K, is equal to minus S of B of K plus S of B of I. What this means is that considering the sequence B1 till Bk, choosing the trainer with the maximum sadness is always optimal because it either gives a better answer or it gives an answer that is just as good as taking any other trainer from 1 to k minus 1. Hence, the solution is to always choose the trainer with maximum sadness. For the implementation, we will iterate over all the days from 1 to capital D, and on each day we will calculate the trainer that has the maximum sadness, and we will decrease its T of B of I by 1. So coming to complexity, since we are iterating from 1 to D, we will do order of D operations, and with each I we will calculate the trainer that has maximum sadness. In the worst case, we can have all the n trainers, Hence, the final time complexity is order of n into d. The space complexity is order of n because we have to store n trainers, and to calculate we do not require any other extra memory. So this will pass the first subtask, however will fail for the second one. For the final subtask, we can improve this operation of finding the trainer with maximum sadness. To improve the complexity, we can use a data structure set that will store the sadness value and the number of lectures that are left. In this set, we will perform two operations. The first is to add. We perform this operation as when the new trainer arrives. Let's say a trainer j arrives on some day, then we will append s of j, comma t of j to this set. For the second operation, we will perform find maximum, which is the trainer that has maximum sadness. So we will pop out the last element of st. So the set st stores pairs in the form of sorted order by s of I. Hence the last element will have the maximum s of I. Then we will update the number of lectures t of I as t of I minus 1. Now if t of I is not 0, that means that there are some lectures left, then we will push the new s of I t of I into st. So now the time complexity for this operation has been reduced to order of log of n, because for each operation in set we use log of n complexity. So the new time complexity is order of d log n. The space complexity is order of n. To store the original input as well as to store the set, we need order of n of memory. Moving on to the code. So I've created a struct to store the trainer object. Then I create a vector of size n to store all the trainers. Then I take the input. Then we sort the trainers according to the arrival day. Why? Because we need to process the trainers that arrive early first than the trainers that arrive late. We create this multiset of pair intent to store the sadness value and the number of lectures that are left. Index is a variable that will point to the current trainer. Now we iterate over all the days. If index is less than n, that means that there are some trainers left and the arrival day of the current trainer is today. Then we insert the sadness value and the number of lectures. We increment index by 1. We do this for all trainers that have arrival day equals I. Now if st.size is 0, which means that there are no trainers that can give lecture today, then we just continue. Else we pop out the last element from this set and we decrement the number of lectures by 1. And if there are some lectures still left, then we append the trainer back to the set st. We use a variable total sadness to store the final answer. Total sadness is basically the sum of all the lectures that are left, which is represented by I dot second, and the sadness value I dot first. Finally, we print the answer. So guys, this is pretty much the whole code. Try to code it yourself, and if you face any issue, then come back and watch it again. So guys, I hope you understood the problem well, and if you have any questions, drop a comment below and like the video, and don't forget to subscribe to get the latest updates from CodeChef. Thank you and goodbye.